Alright, in this video we look again at a family of functions problem and a modeling problem. And essentially what we're trying to do is to find a function f of x, okay? And this function could have parameters. And the goal is to find those parameters, and we would like to achieve a certain goal. Okay, and the goal in this problem is to find a cubic polynomial that actually satisfies several goals or criteria. That this function needs to have a critical point at x is equal to 2. It needs to have an inflection point at 1, 4. And we're not just looking at any function, we're looking at a polynomial function, a cubic polynomial, and the leading coefficient of that function has to be equal to 1. Okay, so there's our goal, and we need to have parameters in that problem, and we would like to figure out those parameters so that we achieve all three of these goals. Okay, one of the goals is easy to accomplish. Okay, the first thing is that we're dealing with a cubic polynomial. So a cubic polynomial is a polynomial that is of this particular form. Okay. It's a cubic polynomial, and we have parameters a, b, c, and d. These are all things that we can adjust. Okay, it's a cubic polynomial, and the leading coefficient is equal to 1. So we know that this leading coefficient, we know the a value now. The only thing we don't know is what is b, c, and d. We need to figure out what these values are going to be. Okay. Now, we know that because we're dealing with critical points and inflection points, we know that we're going to need both the first and the second derivatives. So if you could take a moment to write down those first and second derivatives, we can see what's going to happen. All right, we're back. So hopefully you've had a chance to write down the derivative of this cubic polynomial that has a leading term of 1. The derivative would be 3x squared plus 2bx plus c. D is a constant, so the derivative of a constant would be 0. And f double prime of x is 6x plus 2b. Okay? And we want to have, in this problem, a critical point at x is equal to 2. So what that says is that at x is equal to 2, we need f prime of x to be equaling to 0. Okay? And that tells us that at x is equal to 2, 3 times 2 squared plus 2 times b times 2 plus c, that's supposed to equal to 0. Okay, so that tells us that 12 plus 4b plus c is supposed to equal to 0. So that's what it means. This equation right here comes from this criteria that a critical point needs to happen at 2, which means that the derivative is supposed to be equal to 0 when x is equal to 2. So here is one equation. Okay, we also need to have an inflection point at 1, 4. So we're supposed that the only way you can have an inflection point is if the second derivative at the value x is equal to 1 is equal to 0, which tells us that 6 times 1 plus 2b has to equal 0. So now we know that 2b plus 6 has to equal to 0. Okay? Could you take a moment and look at these two equations and figure out if that tells us anything? Does that tell us anything about what b or c has to be equal to? And use those two equations to make a determination about b, c, or d. All right, we're back. I hope that 2b plus 6 equals to 0 told you that b had to be equal to negative 3. And since b was equal to negative 3, that told you that 12 plus 4 times negative 3 plus c had to equal to 0. So I'm hoping that told you that c had to be equal to 0. Okay? So now we have accomplished quite a bit. The only thing we don't know is what is the value of d. Okay, we've used the fact that we have a critical point at 2. We've used this piece of information. We've used the fact that we have an inflection point at 1, and we've used the fact that we have a leading coefficient of 1. So that was 3 pieces of information, and that helped us to find 3 of the constants. Or sorry, we shouldn't call them constants. We should say that helped us find or to identify 3 of the parameters. Okay. What we're missing is that there is a 4th parameter, and so we need a 4th piece of information. So all we know at the moment is that this function needs to be x cubed minus 3x squared plus d, so c was equal to 0. Do you see a 4th piece of information in this problem? Okay. And that 4th piece of information is right here. It's almost double using some information, that this function needs to have an inflection point at 1, 4, which means that the function evaluated at 1 is supposed to equal 4. The function has to go through this point, 1, 4. So when you put in 1 into this function, you get 1 minus 3 plus d, and there is your next equation that says that 4 is equal to negative 2 plus d, which means that d has to equal 6. So here are all the parameters identified now. And if we put in this cubic polynomial that f of x is equal to 1 times x cubed, okay, minus b was equal to 3 times x squared, plus 0 times x, plus 6, oh, this is supposed to be x cubed, sorry about that, that we now have, not 23rd, sorry, that now we have a function that has a critical point at 2, okay, we can see that the derivative is 0 at that point. We have an inflection point at 1, right, so if we zoom in on this function, that to the left of 1, tangent lines, right, the function would be below its tangent line on the left side of 1, and on the right side of 1, tangent lines drawn would have the function being above that tangent line. So here we can see that we actually do have an inflection point at x is equal to 1, and 1, 4 is actually a point, that's where the inflection point occurs. And our leading coefficient is 1. So here is the function that fits all the pieces of information given, and we have done a parameter identification problem.